LeetCode. In this video, we're diving into a fascinating problem, product of array except self. This challenge tests our ability to think about the arrays in a new light. So let's break it down together. So the given problem statement is, given an integer array nums, return an array answer such that answer of I is equal to the product of all the elements of nums except nums of I. So the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. We must write an algorithm that runs in O of n time and without using the division operation. So if they haven't said without using the division operation, what we would have done is we just use one variable to come and store the product of all the elements in the array, and then while iterating the array, we could have constructed the output array using just like a total product by the nums of I. So that's the other approach if they haven't mentioned this one. So since they haven't mentioned this, we have to use different approach, which we'll be looking at. So this is the given example. Nums is equal to 1 2 3 4 and output is 24 12 8 6. So how did this 24 come? So this is the product of 2 3 4 leaving 1. So 2 into 3 into 4, that's 24. So how does 12 come? So this is the product of 1 3 4 leaving 2. How did 8 come here? So this is the product of 1 2 and 4. Similarly 6, which is the product of 1 2 3. So here nums is given as -1 0 1 3 and -3 and 3. So how did this come 0? Because this is the product of all the elements leaving this one. Since we have the 0 here in all like for all the elements except 0, whose place is 0, we get the product as 0, because 0 would be having part of our multiplication. So anything multiplied by 0 is 0. So except the element place whose which is 0, we get as 0. So that's a thing here. So here, since we compute the output leaving 0, we get as -1 into -6 becomes +3, 3 into 3 9. So that's what given here. So the constraints, the nums length is the inclusive range of 2 to 10 power 5. So elements would be there from in the inclusive range of -30 to +30. And other thing is the product of any prefix or suffix of nums is guaranteed to be a fit in 32-bit integer. So there is a follow-up which we'll look later. The follow-up is like, can we solve the problem in O of an extra space complexity? And they also mentioned that the output array doesn't count as an extra space for space complexity analysis. We'll look into this later at the end of the video. So approach 1, using the two arrays left and right. So we initialize the two empty arrays left and right for a given index I. Left of I would contain all the product of all the numbers to the left of I, and right of I would contain the product of all numbers to the right of I. So basically we keeping the two arrays to compute the compute the product towards left, product towards right, and then so we would need to use two loops to fill in the values for the two arrays. For the array left of 0 would be 1, since there are no elements to the left of the first element. So for the rest of the elements, we simply use the formula like left of I is equal to left of I minus 1 into nums of I minus 1. Remember that left of I represents product of all elements to the left of the element at index I. So for the other array, we do the same thing but in the reverse. So we start with the initial value of 1 in the or of right of n minus 1, that is basically the taking consideration of the last index in the array. So where length is the where n is the length of the nums, given nums. So we keep updating r of I in reverse. Essentially I meant r of I is right of I. So right of I is equals to right of I plus 1 into nums of I plus 1. So we remember that right of I represents product of all elements to the right of the element at index I. So once we have these two arrays populated, we simply iterate over the range from 1 to from 0 to n minus 1. So and we compute the product at each product required at each index. That is result of I is equal to left of I into right of I. So let's go over the code. So here in the code, we have this n initialized to the length of the nums, and then we are initializing the two arrays left and right with the length of the given nums. So we're keeping left of 0 and right of n minus 1 to the 1 1, since we don't have any elements further in both cases. So we're just populating the left is in this loop, and we're populating the right in this loop, and then we just use a under array result to store the result. So result of I would be left of I into right of I, as discussed, and then yeah, we return the result. So here the time complexity is O of n, where n is the length of nums, and space complexity is O of n. Since we use the two arrays here, left and right, so it's actually O of 2n, but it won't count, like 2 is just a constant, right? So we take it as O of n. So here, this, as I said, like output array doesn't count in the extra space complexity. We don't consider this result as an in our calculation of our space complexity. So there's another approach, which is just same, having the same time complexity, but little optimized space complexity. So this, so we understood that the output array doesn't count towards the space complexity. So this approach is essentially the extension of the before approach. Basically, we will be using the output array as only one of the left or right, and then we'll be constructing the other one on the fly. So let's look at the algorithm on this idea. So algorithm, so we initialize an empty array answer, where for a given index I, answer of I would represent the product of all the numbers to the left of I. So we construct answer the same way we construct the left array in the previous approach. So these two algorithms are exactly the same, except that we are trying to save some space. The only change in this approach is that we don't explicitly build the right array from the before. Instead, we simply use a variable to keep track of the running product of elements to the right, and we keep updating the answer by doing the answer of I is equals to answer of I into right, where right is a variable here, not a array. So for a given index I, answer of I would contain the product of all the elements to the left, and right would contain product of all elements to the right. And then we update right as right is equals to right into nums of I. So let's go over the code. So here just we are initializing the n, that is length of the nums. So here the declaration and initialization of the array answer. So he's just populating like left in this previous approach. So the problem, like the solving is different in this for right array. Here we don't compute the right array, like we don't calculate the right array, but we compute it on the fly. So we just keep the right as 1, initialize to 1, the same way we did for the right of n minus 1 is equal to 1. So here for the reversed range means like we take consideration from n minus 1 to 0. So here the answer would become answer of I into right. So this is just like we are taking the consideration of answer, like we are computing the product of left and right at the same point, this same point, instead of having another loop. So and then we update right is equal to right into nums of I. So that's how the right gets the accumulating product of all the elements in the right, and then we multiply with the answer of I. So keeping it the product of left and right element, leaving the current element I. So that's how we compute the answer here and return it. So the time complexity here is O of n, where n is the length of the nums, and space complexity is O of 1. Since the output array answer won't add up to the space complexity, we can give it as O of 1 time complexity. So next is demo and conclusion. So I just added two methods here for just demystifying purpose. So with the approach, so let's compute with the approach one, how it goes. So yeah, answer is accepted, and let's try with the approach 2. This is accepted answer, and let's try submitting this. So yeah, oh, great solution. It beats like almost 93.7% of users with Python. So the space wise also it's optimized 71.7%. So yeah, let's go with conclusion. So with a bit of clever thinking and two-part strategy, we have solved the product of array except self problem without using division. So the solution not only meets the challenges constraint, but also solves it sufficiently. So try coding out yourself and then see how it improves your understanding of array manipulation. So thanks for tuning in.